Hello everyone, in this video we are going to write down the isomers of C3H7N. Let us first determine the degree of unsaturation for this elemental composition to see whether it is a saturated elemental composition or not. Degree of unsaturation is equal to 1 plus number of carbon atoms minus number of hydrogen atoms by 2 plus number of nitrogen atoms by 2. Therefore, this is equal to 1 plus 3 minus 7 by 2 plus 1 by 2. So, therefore, this is 4 minus 3.5 plus 0.5 and therefore 4 minus 3 and that is equal to 1. So, this means we should consider carbon-carbon double bonds when we write structures, or it can also have carbon-nitrogen double bond. That also we need to consider, or it can have a ring, one ring. So these are the three possibilities we should consider. Let's write the structures one by one and also their corresponding IUPAC names. At first I am going to write all primary amines. Primary amines means we should have NH2 group. Basically the nitrogen is directly attached to only one carbon. So number 1, we can write 1, 2, 3 and then the NH2 group and then one double bond here. Let's number it 1, 2, 3. This is prop2 in 1 amine. That's the correct IUPAC name for this molecule. And then number 2, let's shift the double bond 1, 2, 3 and then the NH2 group and then double bond here. This is prop 1 in 1 amine, but now we have cis trans isomers. I'm going to follow EZ convention instead of cis trans. So this is basically what we wrote right now is a trans isomer. The priorities are going to be on the opposite side. So therefore this should be referred as E isomer. In terms of EZ convention, this is a E isomer. So therefore the correct IUPAC name for this molecule is actually 1E in parenthesis and then prop and then 1E in 1 amine. That's the correct IUPAC name for this molecule. Because if you assign priorities as per Kohn-Ingold-Prelog rules, then on this side of the double bond, carbon gets the high priority, hydrogen will get the low priority, because atomic number of carbon is higher than the atomic number of hydrogen. On other side of the double bond, nitrogen will get the top priority, hydrogen will get the least priority. So the priorities are basically on the opposite side. If the priorities are on the opposite side, then we should call this as a E isomer. If the priorities are on the same side, then we call it as Z isomer. So this basically means we have to consider two isomers for prop 1 in 1 amine. One is the E isomer and another is the Z isomer. So the Z isomer we can write it this way 1, 2, 3 and then the NH2 group. So this is 1Z prop 1 in 1 amine, because now the hydrogen atoms are on the same side of the double bond. So therefore low priorities are on one side, high priorities are on one side. So therefore this is Z isomer. And then number 4, we can also write prop 1 in 2 amine. So 1, 2, 3 and then put a carbon-carbon double bond and then NH2 group at a 2 position. 1, 2, 3. So this is prop 1 in 2 amine. The cis-trans isomerism is not possible now because on one side of the double bond we have 2 hydrogens and therefore cis-trans isomerism is not possible for isomer 4. And then number 5, one more isomer that we can write which is a primary amine is this one, cyclopropane ring and then NH2. So the IUPAC name for this molecule is cyclopropane 1 amine, or you can simply write it as cyclopropane amine, because wherever we put the NH2 group, that is going to be number 1. So cyclopropane amine is fair enough. If you want to specify the number, you can specify it. Cyclopropane 1 amine. Both the names are acceptable. Now we are exhausted with the primary amines. Now I am going to write secondary amines. So we are going to have the NH group. And then number 6, we can write NH and then put a methyl group and then 1, 2 and then put a double bond. So this is 1, 2. The IUPAC name for this molecule is N-methyl because we have the methyl group here. So that's why N-methyl, and then eth 1-ene 1-amine. That's the correct IUPAC name for this molecule. And then number 7, we are going to write a cyclic secondary amine, that is this one. So this is azacyclobutane, that's the systematic name, but the proper IUPAC name is azitidine, that is AZETIDINE. Azitidine is the proper IUPAC name, or you can also call it azacyclobutane. But the preferred IUPAC name is this one. And then number 8, we can also write methyl aziridine, but that is going to have a chiral center. So this is methyl aziridine. So we have a chiral center here because there is a hidden hydrogen and then methyl group and then NH on one side and then CH2 on the other side, isn't it? So we have methyl group here and then methylene here and then NH here, and then we do have a hidden hydrogen here. So that means we do have 4 groups around this carbon. So therefore this molecule is chiral. Therefore the correct IUPAC name for this molecule is actually, let's determine the RS notation. So we basically have carbon here. So let me just redraw this. So we have a carbon here, we have a hydrogen here. So obviously hydrogen will get the least priority. Carbon connected to nitrogen, that would get the top priority. And then we have carbon here, but this carbon is connected to nitrogen and then hydrogen because we have 2 hydrogens here, isn't it? So those 2 hydrogens and plus nitrogen atom, we should not count the chiral carbon. So nitrogen, hydrogen, and here for the methyl group we have 3 hydrogens. So therefore in terms of priorities, the methyl group will get the 3rd priority and the methylene group will get the 2nd priority. So if we are looking from this side, and then in terms of Fischer projection, we can write it this way: 3 here, 4 here, and then 1 on top and then 2 at the bottom. Let's bring the 4 down because we can assign the absolute configuration when the least priority group is on the right hand side or left hand side or at top. We need to bring it down. So 4 here, 2, 1 stays where it is, and 3. This is clockwise, that means R, but we did one swap, isn't it? So therefore the original is yes. Therefore the absolute configuration at this place is yes. Therefore the correct IUPAC name for this molecule is in bracket 2S and then 2-methyl aziridine. That's the correct IUPAC name for this molecule. So likewise for its enantiomer 2, we can give the IUPAC name, and that would be 2R 2-methyl aziridine. So 8 and 9 are enantiomers. So we are exhausted with the secondary amines now because we wrote 4 secondary amines. So we are exhausted with the secondary amines. 3 of them are cyclic, 1 is non-cyclic. So let's move to tertiary amines. We can write only one tertiary amine for this elemental composition, and that is this one, C3H7N. We have 3 hydrogens here, 2 hydrogens here, 2 hydrogens here. So we do get C3H7N. This is the only tertiary amine that we can write. And the IUPAC name for this molecule is N-methyl aziridine. We just replace the hydrogen with the methyl group. So therefore N-methyl aziridine. And then we are going to write 4 different imines now. So imines means basically we will have a carbon nitrogen bond. We can write imines in 2 ways. One is either we will have a hydrogen like this here that is attached to carbon, which we call them as aldimine, or we can also write it this way, C double bond N, and then on 2 sides that carbon is attached to carbons once again. So this is called ketimine. Both are possible. So both in general we call it as imine. Number 11, we are just gonna first write a one ketimine structure that is possible with this elemental composition, and that is 1, 2, 3, and then double bond and then NH. So this is basically propane 2 imine. 1, 2, 3. Propane 2 imine. This is the only ketimine that is possible with this elemental composition. Rest of them are going to be aldimines. And then number 12, we can write propane 1 imine, and that is 1, 2, 3, and then put a carbon nitrogen double bond and then hydrogen. So the numbering has to be done from here, 1, 2, 3. So this is propane 1 imine. The difference between propane 1 imine and propane 2 imine is that the carbon atom here has a hydrogen, whereas this carbon atom has no hydrogens. It is connected to 2 carbons. So that's why propane 2 imine is a ketimine, whereas propane 1 imine is an aldimine. And then number 13, we can also write N-ethyl methanimine, that is in bond line notation C double bond N, 1, 2. So this is N-ethyl methanimine. That's the correct IUPAC name for this molecule, because we have the ethyl group here, but we have a carbon nitrogen double bond here. So therefore the name should be based on this one, carbon nitrogen double bond, based on imine, not on the other way around. So that's why it is N-ethyl methanimine. And then number 14, let's shift the double bond, nitrogen methyl group, and then 1, 2, put a double bond here. Let's number it 1, 2. This is N-methyl, because we have the methyl group here. So therefore N-methyl ethanimine, not ethanamine, it is ethanimine. That's the correct IUPAC name. For this particular isomer, do not write it as ethenimine, because if you write it as ethenimine, then what it means is this structure, methyl group nitrogen and then double bond carbon and then double bond again carbon and then 2 hydrogens. So in case if you are writing N-methyl ethenimine, then you are meaning this structure, not this one. These two are not one and the same, isn't it? N-methyl ethanimine, that's the correct IUPAC name for isomer 14. Let me remove this. So we have written 14 isomers of C3H7N and their corresponding IUPAC names.